Welcome to Steometry with Miss Steo and my special guest,
Teddy.
Today we're going to use the Pythagorean Theorem, but in reverse.
To figure out whether a triangle is acute, right, obtuse, or not even a triangle at all.
By the end, you'll be able to look at just 3 side lengths and classify the triangle instantly. Let's get started. You already know the Pythagorean Theorem, which is a squared plus b squared equals c squared. But that only works for right triangles. Today we're using the converse, which means we're starting with side lengths and working backwards to figure out the type of triangle. Okay, let's look at a couple of examples. The first thing we need to do is decide, is it even a triangle? So we're going to play kind of a game. Is it a triangle? So we're going to look at a 5, 6, 7, and we're going to just add a plus b and see if it's greater than, less than, equal to the c, the longest side. So remember, when you're doing a, b, and c, the largest number is always your c. So Teddy, with 5, 6, 7, which number is the largest number?
7.
So 7 is going to be what letter?
C.
Great. So I'm going to go 5 plus 6, and we're going to compare it to 7. Now what's 5 plus 6?
11.
All right, so 11 is greater than 7.
7.
Okay, so when it's greater than, we know it's a triangle. So that's a triangle. Let's go on to 3, 4, 5. So Teddy, which number is going to be C?
5.
Good. All right, so we're going to add 3 plus 4 and then put 5. Now, 3 plus 4 is?
7.
Okay, 7, is that greater, less than, or equal to 5?
That is greater than 5.
Okay, so that is a triangle. Okay, let's go over to another example. 3, 4, 6. So we've got 3 plus 4, and we're going to compare it to 6. What does 3 plus 4 equal?
7.
All right, so 7 greater than 6. So we know that's a triangle as well. So we have 3 triangles so far. Okay, now we're going to go to 2, 3, 6. And which one is our C?
6.
Good. 2 plus 3, compare it to 6.
2 plus 3 is 5.
Uh-oh. Is 5 greater than or less than 6?
That's less.
It's less than 6. So let's look at that one, because that one immediately is going to be our easiest one. So we're going to zoom in to our 2, 3, 6. When that is less, then that means it is not a triangle. So you're going to stop right there.
Bum, bum, ba.
Yep, not a triangle. So if it's less at that stage, is it a triangle, Teddy?
No.
No, it is not. So let's go back to our 3 examples that we know are triangles. So we're going to zoom in and look at our 3, 6, 7, 3, 4, 5, and 3, 4, 6. So I'm going to come down here. Now, I like to think of this as, if it's the converse, we're going to reverse. So I've got c squared on the left and a squared plus b squared on the right. So it's still our Pythagorean theorem, but we're rewriting it so that the inequality symbols, the less than and greater than, are kind of facing a way that makes sense. So I've got c squared is less than a squared plus b squared. So we're going to substitute again. So we've got 5, 6, 7. So we plug in, and we go 7 squared, and then 5 squared plus 6 squared. So we need to see, is it less than, greater than, maybe it'll be equal. Well, 7 squared is the same as 7 times 7, and 7 times 7 equals
49.
5 squared is the same as 5 times 5, and what's that, Teddy?
A 25.
And then 6 squared is going to equal
30 and a 6.
36. Okay, we add our squares together, and so we've got 49 is less than 61. Now, when I think of less than, I think of small. And the type of triangle that's small is one that is acute. And we remember that a triangle is small or acute because something that's small is cute. Aww. It's cute. It's small.
Yeah, so cute.
Okay, let's go on to our next example. We've got 3, 4, 5. Okay, let's put this in. So we've got 5 squared and then 3 squared plus 4 squared. And why do we put 5 in? Do you remember why 5 is C?
Because it's the smallest.
Not the smallest, almost. It's the biggest. Okay, so C is the biggest of the 3 numbers. So 5 squared is 25. 3 squared is
9.
4 squared is
10 plus 6, 16.
16. Okay, and that equals 25 equals 25. Both sides equal each other. When they equal, we are going to have a right triangle. And I like to think of it equaling and being right is if things equal, then things are right on track. Get it? Right on track is equal.
Yeah.
All right, last example. We're going to come over to a 3, 4, 6. So let's plug this guy in. And 6 is C because?
It's the biggest.
Good, it's the biggest number. And then we plug in 3 squared and 4 squared. Okay, we square our numbers. 6 times 6 is 36.
30 a 6.
3 squared is 9, and 4 squared is?
10 plus 6 again equals 16.
Yep. Okay, so 36, and then 9 plus 16 is 25. So 36 is greater than 25. And an obtuse triangle has a big angle. So it's a big angle is a great big angle. Greater than obtuse. All right. So that is how we figure out the type of triangle is coming from this flow chart here. And if this is helpful, pause the video. I'm going to move this up here so that it's a little bit easier to kind of take a picture of or just write down in your notes. But this should be a quick guide to help you figure out what type of triangle are you dealing with. All right, guys, like, subscribe, leave some comments for Teddy to respond to.
And comment if you want more videos
Just like this one. Thanks, everyone.
Bye. See you again.